silver mirror in a Flask experiment is taking the idea of a tolerance test for aldehydes and applying it to coating a flask with a layer of silver. So aldehydes are materials with a this specific functional group or motif that's a part of the structure of the material. So in the case of our starting materials, we have three different solutions. Solution A is silver nitrate, solution B is potassium hydroxide, and solution C is an acidic solution that contains sucrose. So in acid, sucrose hydrolyzes and forms glucose and fructose, which are two different sugars. In the case of our reactions, as we add silver nitrate and ammonium hydroxide together, in a basic solution, we end up with this silver diammonium cation, which in the presence of glucose and fructose further reacts to form silver metal, which is what deposits on the surface of the glass flask and gives it that shiny mirror-like quality. We can actually take the silver and even recycle it and use it for further experiments following the same experiment. So a few different safety things to consider are we are dealing with highly corrosive chemicals, specifically strong acids like hydrochloric acid and nitric acid, as well as strong bases like potassium hydroxide and ammonium hydroxide. In addition, when working with ammonium hydroxide, there is the potential for noxious ammonia fumes to be present. So it's important to do this experiment in a well-ventilated area, such as a fume hood. In addition, silver nitrate can stain your clothes, hands, etc., so it's important to wear gloves. And the final step of this experiment, after we've coated the flask, is to do a waste neutralization to avoid the formation of this unstable explosive silver nitride material. So to do this, we take the contents of what's remaining in our flask, add it to a waste neutralization container which contains hydrochloric acid, which then deposits silver chloride, and then you have a little bit of hydrogen gas that forms as a byproduct.